Okay, this is part two of the linear equation application stuff. So what we have here is a problem that's involving bonds and percentages and stuff like that. So this is a total of $12,000 invested in two different types of bonds, one paying 10.5% and the other paying 12% simple interest. Last year, the annual interest earned on the two bonds was $13.35. How much was invested at each rate? So you could think of this as the amount invested and the amount earned, and what you could do is set up a table. So in the first part, we don't know how much he has in the 10.5% bonds. We can call that X, and then in the 12% bond, we can say that's 12,000 minus X. And then the total amount is 12,000. So the whole amount that they have is $12,000. Now over here in the amount earned, it earned 10.5%. So that's 0.105x. And then the 12% bond would be 12%. So 0.12 of the 12,000 minus X. And that makes a grand total of 1,335. Okay, now to make this a little more algebraic, make more sense algebraically, what you can do is you can set up an equation saying, okay, the 0.105x plus the 0.12 times 12,000 minus X is going to be the 1335. So what you do next thing you do is you're going to go ahead and do the distributive property. So you get that plus 0.1, 12% of 12,000, I believe is 1440, minus 0.12 X, and that's going to equal 1,335. Okay, the next thing you want to do is you want to combine that 0.105x with that negative 0.12x, and you're going to get you are going to get a negative. You're going to get a negative point. Oh, 15x, and that's equal to 1,335, but we're going to minus 1440. So then what I get is I get negative 0.015x is equal to and this is going to be equal to negative 105. And then I divide both sides by the negative 0.015, and I get x is equal to 7,000. So if there's 7,000 here, in the other investment, they have $5,000 invested. All right. There's a couple other things that they might do. Might talk about something that's talking about mixtures. So this is a dietitian needs to mix 10 gallons of milk. That is 2.5% milk fat for the patients at a rehab home. She has some milk that has 4% milk fat and some that has 1.5% milk fat. How much of each should she use? So what helps is usually the table, so or like a drawing. What we do know is that she has some that's 1.5% and some that is 4%, and at the end of the day, it has to all be 2.5%. So what do we do there? Well, with this, we're going to go ahead and say, all right, well, we're going to put 1.5% milk fat here, and then you got the 4% milk fat here, and then here you got the 2.5% milk fat. Now, how much is the 1.5? I don't know, so we'll call that X. How much is the 4%? Well, it's 10 gallons minus however many gallons of the other one we use. And at the end of the day, we have to have a 10-gallon 2.5 mixture. Now, with this, we're going to just use basic, turning the 1.5 into a percent. Now you have 0.015x plus 0.04 times times 10 minus x is equal to 0.025 times 10. Okay, so you can go ahead and distribute that 0.04. You get something like 0.015x plus 0.04 excuse me, plus 0.4 minus and that's going to be equal to, I believe that would be 0.25. So you could probably go ahead and finish the rest of that out. You know, the hard part is done for you. The next one we're going to look at is one that involves distance, rate, time. Now this one says something about John is jogging 8 miles per hour for the first part of the race and then increased his speed to 12 miles per hour for the second part of the race. The race course was 21 miles long and John finished it in 2 hours. How far did he jog at the faster pace? So if you think about the slow pace, his distance was, let's see, what do we know? We don't know how long he took, so we'll call this X. And then we know that his rate was 8 miles per hour. And his distance, because you got to remember distance equals rate times time, his distance was 8x. Okay, now if we think about his fast pace, he did it, he was going at 12 miles per hour and he finished it, let's see, he finished that in 2 hours, so that's going to be 2 minus x. So if you do distance equals rate times time, that's going to be 12 times 2 minus x. Okay, so how are we going to set this up? Well, that's really simple. We just know that the distance of the slow pace, which is 8x, plus the distance of his fast pace, which is 12 times 2 minus x, is going to be equal to the entire 21 miles. Okay, so then we just do a little distributive property, so you get 8x plus 24 minus 12x, and that equals to 21. And I'll go ahead and leave the rest for you to go ahead and figure out. The answer that you probably will get is x is 3/4 of an hour. So it took him 3/4 of an hour to finish. So at the slow pace, that would be 6 miles, and at the fast pace, that would be 15 miles. Okay, so I hope this makes sense. We'll see you in class soon.